Welcome to another module. This module is about engineering sense. I'll describe what is engineering sense and all those. Another way of looking at it is thinking with hands. Okay, humans have done this over the entire age that the humans have existed. Engineering is old. We all know that. It has been in existence since the human civilization existed. Because it was born out of a need, right? Need of the humans to modify the environment for basic needs like food, shelter and security. In Hindi we call it as roti, kapada, makan, right? So that's something that was a need that gave rise to doing things to cater to the needs, making the environment possible for such needs to be provided for. Okay, and we call that as engineering in a broader sense. Okay, the driving force was primarily to the desire to have a better, easier, and comfortable life. And humans have done marvels, have invented such marvels such as wheels, farming for food safety, engines for mobility, guns to protect themselves as well as to hunt, computers today. I am just shifting far after the guns were invented, computers, and today internet, right? Some of them have survived and will survive the test of time. It shows the incredible ability of the humans to mend the laws of nature to make for a better living, right? Now all this has happened because of engineering sense. Back then there were no schools, by the way, right? If you are looking at Stone Age and later ages, there were no schools and all those colleges, degrees were all not existing. Even 2000 years ago, these were not existing. But then man had already secured to a certain extent these things that I was talking about, food, shelter and security. The ancient engineers were not degree holders, but they were engineers, mind you. They observed, studied, honed skills to make the ends meet, right? And that's something that suddenly rings a bell for us, right? Today, thanks to industrial revolution that occurred about 200 years ago, that we have systemized, and that has worked wonders for us, and we are now sticking to it. But there are some downsides to it, and therefore the need for looking at engineering sense. World has been able to achieve economic prosperity, stability, security and so on purely because of this industrial revolution that has taken place. But one thing that has happened today is we have compartmentalized ourselves. You only have specialists today. We have a heart specialist, specialist for this, specialist for that. We even have foot specialist. We have forgotten to understand that the body, our body is not just an assemblage of parts, but more than that. They say whole is more than the sum of the parts, right? We have somehow narrowed down our focus, that we have lost the general view, right? So it is time that we start to think about what to do so that we can't drift away, right? We have to a large extent drifted away from the real value of an engineer. When I say engineer, please don't look at engineer as engineering degree. It is not about degree or degree holder that we should call as engineer, but someone who is able to affect things, makes processes, make products, make things happen so that it entails for a better living. Today we seem to respect degree more than what actual engineering entails. I am sure you will agree with what I am saying here. We have somehow drifted away. There are certain things that we learn, but most of it we don't. But at the same time, our ambitions, aspirations for a better living, for a luxurious living has grown disproportionately. We want to reach places very quickly, safely. We want to reach far places. We have already started doing that. We wish to be able to communicate easily with animation, visuals, right? And we wish to have enough energy and food available for us, more than what we require in a way. But we have not solved those problems yet. There are a lot of challenges that have to be addressed, and it is important for us to be geared up to that. We are in a way ready for those challenges if engineering thinking happens. In my opinion, engineering thinking is seeing a threat today. We all have done well in science and mathematics in our schooling and secured an eligibility to do engineering. And now we have a lot of opportunities to study engineering. And we need a lot of engineers to solve problems of today and tomorrow, definitely, right? And engineering is getting to be more complex, multidisciplinary today, while we are moving towards silos of branches of study. I am a mechanical engineer, I am a biotech engineer, I am a chemical engineer, separating ourselves in terms of branches of study, maybe because the volume is large. But it is very important for us to get a general overview of what it is to say I am an engineer. Okay. We have been able to solve the back of the chapters problems easily. We are so tuned to it, we are so trained to it. We have become masters at it, I would say. But I wish we are ready for taking on the real life problems, real life challenges that face today. Look around this hall. Look around the place that you are sitting in. Tell me one thing that the engineer has not touched. The engineer has made sure we are sitting in a place that protects us from scorching sun, rain, even air conditioning, dust, animals, wild animals, etc., etc. In fact, I am audible to you because I am using a device that amplifies my voice. You have been able to come to this class and earn a degree thanks to the internet facility that has been created by an engineer. So that's the importance of engineering. And remember, it is not about just a classroom learning or receiving a degree that is important. And that's why I am talking about all this. It is about making it possible for all of us to live with dignity and aspirations and our needs fulfilled. This cannot happen unless one immerses into the profession called engineering. Because after all, engineering is to do with creating products, processes, services that can uplift a human society. Is it not? Not just the basic needs. Basic needs are met. We have gone far, far beyond today. So, the question that we will ask is, what does an engineer need to have as skills, and what habits make up an engineer? Okay. When I say an engineer, I mean the real engineer, not the degree holder per se, right? Who is able to create products, processes and services for the better living. right? And mind you, engineering is a habit. This is something that I want to stress again. Engineering is a habit. And if we all cultivate that habit, irrespective of what degree we get, etc., right, we should practice this in our day-to-day living. And therefore, what should a 21st century person or engineer in you should train to be able to do and create such habits, such engineering mindset? Well, there are a bunch of habits that we can practice to develop our engineering sense or an engineering mindset. And this will help us immensely in terms of tackling challenges, problems that we face in daily life as well as in our profession. So, in this module, we hope to sow some seeds in your mind about what they are, at least some of them, and how to practice with practical examples. All right, we will give some practical examples and also give you an idea of how to practice them. What are the simple ways through which it is possible for one to learn this engineering sense? Mind you, all these are qualities or habits that one can easily learn. Okay. The simple ways could be in terms of asking questions, it could be certain examples or demo that gives us an idea, it could be activities related to whatever we are in, right from putting a stand for a scooter to be able to figure out how certain things can be taken care of. So, it is in a way mindset, right. So, let us ask this question as to what are the habits that will entail an engineering in me. I need not be having an engineering degree, but what is it that makes me an engineer for myself? Okay. The first and foremost, I would say, for an engineer is planning. In fact, this word engineer, if you go to the root of this word means actually a plot. To engineer a plot is something that they do, they say, right. So, it is a plot or a plan, and therefore, every engineer, everyone who aspires to have engineering in them should learn how to plan. And what is planning? Planning is the process of arranging what tasks to do, how to do, and to optimally use resources to make it more effective and efficient. Right? That is planning. It helps in several things, including safety. It utilizes proper proportions. So, when you plan, you will plan for proper proportions of resources within a stipulated time, all organizing towards achieving a goal. For example, if I have to build a table, okay, I am just taking an arbitrary example. So, what should I do? I should now think about it. Let us say I am a carpenter. Even if I am not a carpenter and I am let us say an amateur, first thing I have to do is I have to plan, okay, what materials should I have? Okay, I need to have wooden planks, I need to have for the leg of the table either the planks or rods, wooden rods, nails, paint, etc., in right quantity. Okay, this is something that I need to do in terms of planning. Right. Now, plan on what tools to use, because without tools it is going to be very tough to make the table. So, what tools to use, whether I have those tools, can I procure those tools, where to build it, right, I need a place to build it, how do I transport the material, all this entire what is called planning. And a lot of planning is necessary even for that small activity that we are talking about. So, as you can realize, planning is an important habit for everyone, and definitely for an engineer, right? Because after all, it is an engineering sense. And when we practice this planning over and over and over, it becomes our second nature. And this is the first habit, I would say, the foremost habit for the engineer in me. Coming to the next habit, which is also a habit that is commonly found for somebody who has that engineering bent of mind. For example, if I have a cubicle room or a cuboidal room, and let's say I have a nice ruler, let's say a foot ruler. Remember, a foot ruler can also measure in millimeters, all right. So I say, let's say I measure the room, one side of the room, because it is cuboidal, I measure one side of the room, and let's say it is, I found it to be 2 meters and 5 centimeters. Now, what the engineer in me would do is look at it, oh okay, it is 2 meters and 5 centimeters, so it is 2.05 meters, right, and I have to multiply this 3 times in order to get this. What I would do is I would make an approximation. The crude approximation could be just 2 meters into 2 meters into 2 meters. Okay, it is 8 cubic meter is the volume of this room. If I had to be a little bit more precise, I may probably add saying, okay, also add this 3 times 0.05, right, that's 0.15 that I get, so that I make it 8.15 as the volume of this, right. I can be going on with precision, but an engineer would want to know a ballpark figure, 8 cubic meters or 8.1 or 8.2 cubic meters. That approximation gives us power to immediately calculate. For example, let us say it rained yesterday, and I wish to estimate how much of water would Chennai, because water-starved places, one of the water-starved places is Chennai, right? That is what we think. But when we calculate, it is not so. So, the amount of water the the rain would have fetched for Chennai, and what would have been the amount of water Chennai would have received from this rain. Let us say I want to find out. How do I go about? An engineer would do a very simple thing, would put say a circular tub outside in the terrace when it was raining, and to measure how much of rain has come, would go back after a day, look at how much water has been filled in that tub. Let us say it has filled about 3 centimeters. Then I know the rainfall for yesterday was 3 centimeters, and if the entire Chennai has received this 2 or 3 centimeter rainfall, then I just have to multiply the 3 centimeters with the area of Chennai, and I get an idea of how much water the rain has brought to Chennai. Remember, all these are estimates and approximations. That's another quality, another habit an engineer should build over and over. Recently, demonetization occurred. So, one of my friends was asking this question. So, what do you think is the volume of transaction that happens in India every day? Good question, right? So, immediately our thoughts go towards estimating, okay, what could be the transactions. Oh, okay, I am doing this transaction here. So, if I take only a particular, let us say, part of the city, this is what is happening. Can I now extrapolate? And therefore, our mind now goes towards approximating and estimating, because that idea gives us some perspective of what is happening. Okay? And therefore, this second habit, I would say, is the habit of approximating and estimating. Right? The next habit is what is called technical auditing. What do I mean by that? So, let me start with an example. Let us say I have a ball, I bounce the ball. So, I just leave the ball, it goes down at a particular height. Let us say the height is 2 meters or 1.5 meters, whatever. Right? I drop the ball. Now, if I ask the question, will the ball reach where I dropped, the height where I dropped? The answer often is, as you already know, is that the ball will not reach that particular height, which means what? It has lost some potential. Where did it go? So, if I ask that question, what I am doing is I am doing a technical auditing. Why? Because energy is conserved. It is a quantity that is conserved, right. So, if it is not reaching that particular height, then it means that somewhere it has lost the energy. Where did it lose the energy? So, if I ask the question and probe, oh okay, it could have been because some heat is produced when it is impacting, right, some friction is there, right, there may be some internal friction, right, there may be some sound that is coming, and therefore, it is just releasing some energy to the air surrounding it, so on and so forth. But what we do here is to estimate what would be the loss here and there, and such a technical auditing also helps in terms of predicting what could really happen. Okay. Right. So, remember, this is very useful in daily life also. Supposing I take a bag of cement and a bag of sand and I mix the two, will I get 2 bags of sand? I am sorry, 2 bags of cement sand mix? The answer depends on the question that I ask, which is, what is the quantity that is conserved? Is it the volume that is conserved or the weight that is conserved? Right? Naturally, you all know it is the weight that is conserved. There are interstitial gaps that are existing in sand, and the cement could probably go and sit over there inside. And therefore, if I mix the 2 bags, I may probably not get 2 bags of cement sand mix, maybe lesser than that. But the weight, total weight will be the same. So, we ask that question, what is conserved, right, and check for that conservation, okay, and that is what we call as technical auditing, because auditing here tells about, oh, okay, what is balanced here, okay. It is a very good habit. I have personally used it in various occasions. When I was dean, I even used it for the number of people staying in the hostel, because we only have a total of this many rooms, right, and therefore, the occupancy is to be conserved. So, I could use that in order to get an estimate of what is really happening. Let us go to the next habit. Okay. For the next habit, I have something that I want to show you. Okay. Let me start with an example this time. Okay. You can see this. This is a plastic cover, a plastic sheet. Okay. This plastic sheet, if I have to, let us say, tear it, it becomes very difficult for me to tear it, right. You can try it at home. This is a transparent sheet that I have used, and plastic sheets are something that you already are having a plenty at home. Just try this out. It is very difficult to tear it, right. But on the other hand, if I take a pair of scissors and cut a little bit, very small, you can't recognize the cut as you see it, but it is possible for me to tear it very easily. See, I have been able to tear it very easily, right. Wherever I have made the cut, I can easily tear it, right. So, from this what do I learn? That if I make a small cut, it's easy to share the, I'm sorry, if I make a small cut, it is easy to tear the sheet. This is something that I learned now, right? Now I'll ask the question, where can I apply this? So the engineer in me now says, oh, okay, I know something that I've been able to learn. Where do I apply this? Maybe you would have seen these notebooks where there is a perforation, so that when I tear it, it nicely goes along this perforation. That's really to do with very similar to what I have done here, a small cut. There are many examples of that sort that happens because I have learnt a particular technique, a phenomenon, and now it is possible for me to apply that phenomenon or the learning in various things, right? See, man learnt if he had two rough stones and scratched back and forth, it would produce heat and therefore could produce fire, right? He learnt it. She learnt it. When the human learnt it, he or she could use it in order to create fire, right? The engineer in them could connect this heat that is produced to how they could burn something which is dry, right? So that's the fourth habit. Where can I apply what I learnt? Where can I apply what I learnt? Okay. The other habit, we already learnt it in systems thinking. It is about cause and effect, relating cause to the effect. How does it help? For example, for the fire to happen in general, for the fire to happen, if I understand that it is the surrounding oxygen that helps in oxidizing, charring, let's say wood or whatever, that is responsible for the fire to occur, then I know what is the cause. Supposing I cut off the oxygen, then burning cannot occur because I have cut off the cause. The effect is no burning. If the cause is oxygen, the effect is burning that can occur, right? So we start to relate these two together. Supposing something is, has caught fire, what shall I do? You know what people do, right? They just put a blanket over that. The reason why they put the blanket over that is because the amount of oxygen that is available within that blanket is small, right? Once that oxygen is exhausted, it has no more oxygen and therefore the fire gets put off. So it's a very effective understanding when we are able to relate root cause of something. Okay, I call it as cause and effect habit, cause and effect understanding habit. Okay, or you can say root cause analysis habit. There are several examples that I could give, but I think this one example is good enough for you to understand the reason why this habit is also a very important habit to create the engineering in me, to create the engineer in me. Humans have never been satisfied with a particular version of a product or a process or a service that they have come up with. Do you agree? I'll give an example, the simplest example that you are very familiar with, which is a computer mouse, right? All of you are familiar with computer mouse. The first version of computer mouse was a bulky one. I don't know how many of you know. where you need to move one direction and the other direction. That was the computer mouse that was available at that time, the first version of it. But the human was not satisfied with that, wanted to bring the size down. And then we had this rolling ball mouse, right? As we move the mouse around, there is a rolling ball that was activating actuators in the two directions, so that it is possible to locate where you are moving the mouse and therefore the cursor in your screen. Later on, there were problems, right? And engineer in us wanted to solve that problem. The ball would not rotate properly. The surface dependent property comes into picture. So we moved to an optical mouse, right? An ergonomic mouse. How comfortable am I with the hand, right? Today we have even graduated to just using gestures for locating etc. in our computer. We have come a long way. How did this happen? Because of one question, which is a habit that an engineer should ask over and over. How can I make it better? The moment I ask that question, how can I make it better? The first thing that appears in our mind is, oh, okay, where is the problem that I can identify? Right? Once I identify the problem, I seek to now correct that problem so that a better version starts to exist. Okay. In a way, this is good because this is like the growth mindset that we talked about earlier, where we ask that question, how do I learn? Right? In this case, it is about a better version of a product, process, or a service that I am able to bring out. Let's go over to another habit. When Edison came up with DC power, one thing that he was not able to do is to supply this DC power to far distances. The reason why it couldn't be taken to far distances was because there was so much of dissipation that would occur when this DC power is taken from one place to another through a cable. And then came Tesla's idea of using AC, alternating current. And this alternating current was able to travel long distances. That's how even today we have alternating current available to us easily, because it is possible to transport through cables easily. But then things have changed today. The power generation, the electrical power generation is no more centralized, or at least in the coming years that's what we will start to see. Which means what? The power is generated locally. How? Let's say solar power. If solar power is generated locally, it may be a worthwhile exercise to spend that power within the neighboring region of the power generation. Look at what has happened. The perspective that time was to take the power to a longer distance. The same thing after so many years, when we look at it now, the perspective has completely changed. Because the power that we extract now is like a DC power directly coming from solar cells, and the power is available locally as long as I put the solar electrification systems. So the change of perspective could bring back certain things that were just ignored or let go, right? And therefore what happens is, it is better that we understand the current perspective And based on the current perspective, we examine all those solutions that even existed earlier and come to a conclusion as to which one is the best. Now, never to throw away something which was a solution that existed earlier and progress has occurred. Here, how can I make it better is through understanding the current perspective of what is happening, the situation that is there, right? Because we are now moving towards renewable energy, clean energy, and therefore clean energy, the way that the clean energy is extracted is very different from how it was earlier, and therefore this change in perspective has given rise to using DC power. IIT Madras is working on a large such electrification projects in India. Let me go to the next habit. The next habit is to do with big picture thinking. Do you remember we did this in systems thinking? Big picture thinking. Having a global perspective, a broad perspective of what is happening. It could be spatial or it could be temporal. What do I mean by that? If I ask the question, what's the bird's eye view of the particular situation that we are looking at? I am now talking spatial, space oriented. If I ask the question over time, what has happened or what would happen to a particular phenomenon or something, then what I am doing is I am now looking at a big picture which is time specific or temporal. So, this big picture thinking helps in terms of understanding an overall aspect that would be missed if you are going into detail, right? And therefore, this habit of going to big picture and coming back to detail, going to big picture, coming back to detail is something that one should develop in order to be able to be in the right direction of coming up with a solution. It's a very important habit. You already know because we have dealt with that in systems thinking and we have given several examples. Another beautiful habit, to me it is something that is a personal best habit, is the idea of abstraction. What do I mean by that? Supposing, let's say I have a nail and I need to drive that nail into the wall. And I ask the question, what's the mechanism behind which I can do this? Yeah. But comes the answer from you, oh okay, just take a hammer, right? As if hammer is the only way by which it is possible to drive the nail into the wall. But what is the function of that hammer? What is it doing in order to be able to drive the nail into the wall? The answer is to do with producing an impact or an impulse. So, in a way, instead of calling the hammer, it would be a good idea to call that tool called hammer as an impact generator or impulse generator. The moment I switch it to that kind of principle oriented name, I am now abstracting it. And now if I ask that question, what other ways are available for me to create the same impulse, I would have several answers. I could probably have, let's say, a firecracker near that nail and place it in such a way that once it explodes, it produces impact, it produces impulse by which the nail could go in. Right? I am just giving a crude example here, but the idea is abstracting. At the same time, I should do also the other way, which is If I have now zeroed in on this abstraction called impulse generation, then I ask that question, what is one simple example of this impulse generator? Then it's easy. I would say, okay, hammer, right? So both detailing and abstraction are important habits that one should create for themselves. So how do I now imbibe this habit of abstracting or abstraction and detailing, right? Very simple. You have to ask one question, which is, what is the mechanism behind, or why is it that hammer is used for nail? If I ask that question, the answer would be, oh, okay, it is producing impact, right? So that why question takes you to the abstraction, a higher level understanding. And if I ask, how do I make an impact? How do I generate an impulse? Then I'm now asking a how question, right? This how question will lead me to a hammer. So if I ask why question and how question, it is possible for me to go towards abstraction or towards detailing. Both are very important for an engineering mind to solve problems, to be able to come up with innovative solutions. Now we will move to another habit. Okay. This is often a habit that typically every engineer would endeavor to have, and I would call this as divide and conquer. Okay. So if I have a system which is a large system, I would look at this large system as system consisting of several functions. Right. Now I have divided the system into several functions. I could do this in dissecting our system or coming up with a design of the system, right? So breaking down a particular problem or a task into sub problems or subtasks helps one to easily solve or accomplish a particular goal. Therefore, it is good to have this kind of a habit where we look at something. Let's say if I take a printer, then I will start to look at, oh, okay, there is a feeding function, there is a carbon deposition function, there is a rotating mechanism function which takes the paper along, etc., 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 right? So several functions that I can separate into, right? And each would have a sub function. These sub functions are connected in order to accomplish a particular goal or a task. This is a very important understanding as far as designing is concerned or reverse engineering is concerned. Okay. So if I have a product, and I want to find out how it works, what are the functions that go into this in order for that to work, then I am asking this question. Okay. And what I am doing basically is dividing and conquering, or in other words, dividing into separate functions or sub functions and looking at the connections between one function to the other, so that I start from, let's say, feeding a paper to the printer to the printed paper coming out. Okay. In fact, I would use another example which is not related to engineering. That's why I said engineering in me could also bring about an understanding beyond the so-called engineer should be looking at. When the Britishers ruled us, the way that they came about ruling us is not like how it happened with the Muslim conquerors. The British did a very smart thing, very different thing. They started dividing the kingdoms. The moment the kingdoms divided, Then they fought between each other, and the Britishers took advantage of it and conquered both the kingdoms, right? And this went on and on, so that they conquered the entire, they could colonize the entire India. Why just India? So many countries. Just a simple principle of divide and conquer. I am not asking you to conquer that way, but I am just telling you the benefit of looking at any system or a process or a situation to be consisting of several functions, several sub-functions. The next one, in terms of creating a habit, as far as an engineering mind is concerned, is about classifying based on functions, based on form, right? It helps us in terms of communicating. As I already told you, when I say hammer, the name hammer has to do with a particular function, correct? For example, if I say a lever, what is a lever? We all studied that in our for probably 6th standard, 7th standard, correct? A lever is something that produces a mechanical advantage by certain manipulation of the mechanical system. Okay, you would have an effort, you would have a fulcrum, you would have a load. The effort that you put in would be such that you would get some advantage in terms of this lever that we have. There are three different lever mechanisms, etc., etc. Let's not go into details, but one thing that comes out of this is, the moment I say lever, immediately this mechanical advantage comes into picture. And this lever is the taxonomy. I am using this word taxonomy that is built into our system, built into our understanding. Right? And by the way, the word leveraging comes from such a realization. Right? Supposing your mom asks you to go, please go buy rice. What would be the question that you would ask your mom? Mom, how many kgs? Right? The question that you ask relates to a measurement, a unit, a dimension, right? And this matters a lot. You didn't ask how many milligrams, right? You asked how many kgs, because it's a relevant unit that could be used for rice. But if you ask a mill owner, how much rice is there in your godown? The answer would be in terms of tons. So these numbers matter a lot for an engineer, right? Oh, it's very hot. The question that arises in an engineering mind would be, oh, okay, what's the temperature, right? So because the relationship between temperature and the feeling of hot is related to the scenario that we are talking about, right? They may also relate, an engineering mind also would relate the quantity to something that we experience. For example, what is a ton of weight? A ton, if I can understand it to be, let's say, about 15 times the average weight of an adult, it gives me a ballpark figure or a picture. Oh, okay, this is what the rough idea, rough sense of what a ton is, right? And that's the power in terms of talking about dimensions, units, and numbers that relate to that. In fact, if you look at it, humans used the measurement of length. For example, if they wanted to measure the size of the room, what they would do is they will put 1 foot over to the next, to the next, to the next, and find out how many feet is the length of the room. assuming that an average adult's foot would be of more or less the same length. Okay. And then some standardization occurred, etc., to call what is a feet, what is a meter, and so on. Okay. Expressing measurements is the key to understanding. For example, if I have to talk about distance between, let's say, sun and earth, or two stars, or from between earth and another star, we will not be talking about miles, we will not be talking about kilometers and so on. We would be talking about in terms of light years. And one light year is the distance that light travels over a period of 1 year, right? So now distance is used in a completely different way in order to make measurements that are very, very long. So this question of, oh, okay, how much is it, what is the quantity that we are talking about, etc., is another habit that an engineer, a typical engineering mind would have, an engineering mindset would have, because it helps in terms of estimating, in terms of understanding, etc. A very useful habit to create among ourselves. If I go to next habit, the next habit has to do with very similar to what we did in systems thinking, where we related one system to another system and look at the parallel between the two. So, supposing I have solved one problem in one situation, then I know how I solve the problem in that situation. So, when I see a very similar situation, perhaps not the exact situation, but a similar one, then my mind tells me, oh, okay, can I use how I solved the other situation and use that method to solve this situation, right? When we do this, we now are able to solve something which is a new problem that has arisen. So, seeking to solve the problem at hand by looking at the experience that we had with other systems that we solved, other challenges that we solved, is what I call as associative understanding of features. There are some features that are utilized in terms of solving a problem which is different from the problem that I am right now solving, but the features, some of the features are common, and therefore I will adopt a similar approach in order to solve the problem. If I need to separate from, let us say if I have to filter, right? I have to filter, let us say I have to remove the husk that is coming along with the rice that has been dehusked. Then what I would do is I would use a blowing of air. By blowing of air, it is possible to remove the husk, because which is lighter and can be dragged by the wind compared to the more heavier rice, and therefore it is possible for me to separate husk from the actual rice. Now I can use this as a principle, as a feature in some other. For example, in textile industry, how they clean cotton is a very similar approach, by blowing air. In fact, that Panchatantra Kada, the Panchatantra story that you know of, about the crow using stones to displace water so that the water level rises and he is able to drink, has to do with thinking about stone occupying a space and therefore displacing water is the feature that has been used by the crow in order to be able to bring the water to a level so that it can quench the thirst, right? And that's something which is powerful enough even for a crow, right? Definitely for a human. Very often we come across a concept or an idea But we don't know whether that idea works or the concept works. And we don't have the equipment to test the concept. What would we do? One of the things that we do is we would come up with crude experimentation. Okay. For example, um, how much height uh, can I take an egg above the ground so that when I drop it does not break? Okay. Let's say the idea is about, oh, okay, as long as the height to which it falls is less than a particular height, then it may not break. The way that I will test it out is very simple. I will just drop an egg, right, on whatever surface that I have right now, to get a ballpark figure of, oh, okay, is it breaking? I may probably test 3 or 4 eggs to test. Oh, okay, it is working. It seems to be okay if I drop, let's say, 2 centimeters from a surface. We call this as jugular experiments. Jugular experiments are just simple rough experiments to understand a concept, understand an idea. Okay. For example, the previous habit I talked about, husk and rice. Now, the experiment that I conduct by blowing the air and seeing whether the husk is getting removed and the rice stays could be a jugular experiment. When it works, then I will go for further refining, etc., etc. But the first level is to ask that question, is it possible? Is it something that I am able to now to a certain extent establish? We call these are doing jugular experiments. Jugular experiments may not need too much of equipment or measurements, but just to create an understanding, a feasibility of a particular concept or idea. I have listed quite a few habits. This is not an exhaustive list. This is just a modest list that I have described so far. There are also other discussions that I have had with some of our co-facilitators. Have a look at those. And my sincere advice to you is to use these in your daily life to make it a better life that you can lead. Thank you.